Nandish, please rejoin again. There is some technical problem. Ask Nandish to rejoin again. Just inform Nandish. Jyoti present? Okay.
Present, sir.
Right. Kiran? Kiran? Lakshmikant? Mantesh?
Yes, sir.
Mantesh?
Yes, sir.
Okay. Mole Prem? Okay. Nagesh? Nagesh? Nandish?
Present, sir.
Just inform Nandish somebody.
Present, sir.
Okay. Right, right. Pooja? Pooja? Pramod Kumar? Praveen? Priyanka? Priyanka? Sandhya? Santosh Pujari? Santosh Sonar? Shahbaz?
Yes, sir.
Okay. Shafia?
Present, sir.
Okay. Shafia?
Present, sir.
Right. Then Sridhar? Sridhar? Srushti?
Present, sir.
Okay. Siddharth Varnekar? Siddharth Patil? Supriya? Vandana? Vasant? Vedata? Yogesh? Mahesh? Balesh? Taik Mohammed?
Yes, sir.
Okay. Praveen? Abhishek? Aishwarya? Amanullah? Bandrokar Tanay Mohandas? Bhavrav? Shodhan?
Present, sir.
Okay. Devanar Anil Kumar Shekappa? Nand Kumar? Pramod? Rohini? Rohit? Shashidhar?
Yes, sir.
Okay. Sridhar?
Present, sir.
Right. Snehal? Vaishnavi? Saish?
Present, sir.
Okay. Kartikyam? Kartikyam? Right. Anybody else join?
Sir, Aishwarya.
Okay. Aishwarya. Okay. Anybody else?
Sir, Prem.
Prem Mole I have marked. Anybody else?
Roll number 22. Nandish.
I have marked. Yours I have marked, Nandish. Okay. All right. We are discussing about accessing the code ROM space that I just told in the last class that I will be explaining about the accessing of code ROM space, and then we'll continue with the next programs. Are you able to see the screen? Are you able to see the screen?
Yes, sir.
Sir.
Okay, okay, right. Now, this is all about the accessing of the ROM space. ROM space is nothing but the ROM memory where we are storing the programs for the code, right? Now, when we are storing the code or the program in ROM memory, actually what is stored? The opcodes are stored. Opcodes of the instructions are stored in ROM memory, correct? Now, when we are storing these opcodes in ROM memory, right? Then what about the RAM memory? This is about a ROM memory where we are storing the opcode. In RAM memory, we are storing the data, and we know that the size of the RAM memory is 128 byte in 8051 microcontroller. This RAM memory we can use for reading the data or for writing the data, right? And we can access this RAM memory directly, that is using the direct addressing mode, or by using the indirect addressing mode, that is using the registers R0 and R1. Correct. Now, when we use the ROM memory for opcode, it is a different thing. But when we are storing some data into the ROM memory, that makes the difference. Okay. Now, what is the difference here? When we are storing the data in ROM memory, say we are using the instruction movc a comma at a plus dptr to access the data that we have stored in the ROM memory. Data, it is not the opcode, data we have stored in ROM memory, and we are accessing that data using the instruction movc a comma at a plus dptr. Now, when we are using the ROM memory, actually the ROM memory is meant for storing the opcodes, the instruction opcodes, right? But when we use it for storing the data, there are two problems here. One problem is that when we store the data into the ROM memory, then what will happen? The remaining memory will be less for storing the opcodes. When we start storing the data into the ROM memory, the available memory for storing the opcode will become less. It will become less. That is one problem. Then another problem is that we cannot write into the ROM memory during execution of the program. When the program is executing, the data cannot be stored into the ROM memory, right? So these are the two problems that arise when we want to store the data into the ROM memory, into the code memory, right? Now, what is the size of ROM memory in 8051 microcontroller? How much is the size of ROM memory?
4 kilobytes.
4 kilobytes, exactly. It is 4 kilobytes. Okay. Now, what happens here is that when we start storing the data into the ROM memory, right, the available memory for storing the opcode will become less. So now, what the designers have done is, the manufacturers, what they have done is, they have made a separate memory space for storing the data if we want to store the data into the ROM memory. And that memory space is nothing but the external memory space. They have allotted 64 kilobytes of external memory for RAM memory, 64 kilobytes, and for ROM memory, 64 kilobytes for 8051 microcontroller. Now, in this external memory space of 64 kilobytes for RAM and ROM, we can store the opcode in the ROM memory, and also we can store the data into the ROM memory if we wish. Okay, if we wish, we can store the opcode in the ROM memory. That is, we have to store the opcode in ROM itself. But if we want to store the data into the ROM memory, that data can also be stored into the external ROM memory that is meant to store the data into the ROM memory. Okay, so now this is how the accessing of ROM space in 8051C is done. Okay, so this is just a overview of how the ROM space is accessed, right? Next, we will move on to a simple program. Write an 8051C program for hex down counter. We are writing a C program for hex down counter, and let us write a program for this hex down counter. Now, what is meant by hex down counter? It starts from FF, FE, right? FD, FC, FB, FA, like that. It goes down. So from FF, it has to reach up till 00 or whatever specified value we have taken in the program. It will go down up till that particular value. That is the hex down counter. Okay. Now, for this hex down counter, we have to write a 8051C program, right? Let us write a 8051C program for this hex down counter. Now, as usual, begin with the header file, hash include reg51.h, reg51.h, main function, void main. Okay. And what would be the next part of the program? What we are supposed to do, the next part of the program? Yes. So we are going to initialize. Unsigned factor. First thing is we have to initialize the loop index. Then whatever data space we are using, let us say we are using a space of 100 memory locations. We want 100 memory locations, 100 values, 100 datas, right, to be stored. Then we have to define that memory location, unsigned character, my data of 100 values or of 100 memory locations will be allocated. That much space will be allocated in the RAM memory here. So it's a RAM memory space of 100 continuous memory locations. It is called as contiguous. Contiguous memory locations means continuous memory locations will be allocated into the RAM memory space. Okay. Then we are going to define the loop index, unsigned character X. Then let us write the C program. I mean the for loop. Sorry, for loop for x equal to 0, x equal to 0, x less than how many values? 100 values. So x less than 100. It starts from 0 means 0 to 99. It is nothing but a count of 100. It starts from 0. Count is starting from 0 means 0 to 99 is nothing but count of 100. Okay, that's why we have to take less than 100. Then x plus plus. X plus plus. X plus plus means x is equal to x plus 1. Correct? Then here we are going to write a statement z. One more variable we are defining here, initializing here, x comma z is equal to 0. Now z minus minus. The meaning of z minus minus is, we will write a comment here, z is equal to z minus 1. Z is equal to z minus 1. That is the meaning of z minus minus. Instead of writing it as z equal to z minus 1, in C language it is written simply as z minus minus, which means that z is equal to z minus 1. Clear here? Then next what we are supposed to do, we have decremented the value of z, 0 minus minus. Now what is the first value in z? 0. I have initialized it to 0. Right? Now when I have initialized it to 0, now 0 is equal to, z is equal to, what is the operation that is performed here? Z is equal to, z is 0, 0 minus 1. 0 minus 1. Now in hexadecimal, this operation is performed like, now if we are incrementing from FF, say we have moved uphill from FE, right? We have started with FE, FE hex, FD, FC, FC, FD, FE, FF. So we have incremented uphill FF. Okay, the counter, it is up to the counter, let us say. Now after FF, what will be the next value? After FF, the next value will be 0. It starts again from 0. Now FF plus 1, this will be 0, 0. It is not the next value. Because in a register, it can store a maximum value of how much? Maximum value of 8 bits. So maximum value of 8 bit means it can store maximum FF, that is 255. Hexadecimal it is FF, 8 bits, 11111111. It cannot store more than FF because the size of all the registers in 8051 microcontroller is 8 bits except DPTR and program counter, PC registers. Is it not? Therefore here FF plus 1 will be 0, 0. Now similarly, if I take it in a other way, now what is the meaning of other way? If I am starting from 0, if I am starting from 0, if I decrement it, 0 minus 1, now what should be the value? If I am taking it the other way, reverse order, 0 minus 1 should be how much? FF plus 1, it will go down to 0 and starts from 0. Now if it is say 0 minus 1, where it will go? It will go to FFH. It will go to FFH. It will go to FF, reverse. FF plus 1, so it will go down to 0, starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Like that, it will go up till FF. Suppose, say, if it is at 0, if you are decrementing by minus 1, then it will go to FF, the top value, the topmost value, and it will start decrementing, minus 1, FF minus 1, FE, FE minus 1, FD, like that. It will go in a reverse order. Are you getting the point here? So this is how it works. Z is equal to Z minus 1. That's why I initialize it first to 0. We have to initialize it to 0 and then go on decrementing the value to get the hex down counter. Now once we have done this, Z minus minus, Next, I have to assign my data of X, my data of X, my data of X. I have got already the X down counter, but I have to store it somewhere. I have to see the display of the down counter. So that what I am doing here, for that, my data of X, my data of X is equal to Z. Whatever these hex values I am getting stored in Z, that I am assigning it to my data of X, so that it goes on storing in these memory locations. First memory location I get FF, then in second memory location my data of 1 I am storing FE, then my data of 2 FD, my data of 3 FC, like that. I go on storing these values in my data of X. Okay. Then if I want, I can also see the value on the put P0, P1, P2, P3. For that, what I have to do, I have to again assign P1 is equal to Z. P1 is equal to Z. Then close the for loop first, then close the main loop. This is how it works. First, define the RAM memory locations, right? Now here it counts for how many it goes on, but while storing it stores only 100 values. Are you getting the point here? Because here we have taken the values, the maximum value as 100 values. Continuous memory locations we have allocated is 100 memory locations. It stores only up till 100 values. Okay, it cannot store more than beyond that, more than that. Okay, this is how the program works here. Is this logic clear here? Logic and the program. Everybody understood here? Everybody understood this? Logic and the program? Everybody understood this?
Yes, sir.
Logic and the program? Right.
Sir.
Okay.
Sir, one doubt ಐತೆ ಸರ್.
ಕೇಳ್ರಿ ನಂದೀಶ್.
ಸರ್ ಅದು FF ಇಂದ 0 ಬಂದ್ಮೇಲೆ ಮತ್ತೆ 0 - 1 ಲೂಪ್ ಆಗ್ತದೆ ಸರ್ ಮತ್ತೆ ಅದು.
ಹೌದ್ರಿ, ಲೂಪ್ ಆಗ್ತೈತ್ರಿ. ಅಂದ್ರೆ ಹೆಂಗ್ರಿ, FF ಫಸ್ಟ್ ಈಗ ನೋಡ್ರಿ, ಫಸ್ಟ್ ಇಟ್ ಈಸ್ ಅಟ್ 0. Okay, FF -1. Okay, I will write down here so that you'll understand. So next value will be FF -1, that is FE, then FE -1 it will go, Z is equal to Z -1, because that is how we have written the logic here, Z is equal to Z -1. So FE -1 will be FD, correct? Then again,
Sir,
FD,
it will go on up to 0 now, sir, after.
The 0 mata, it will go on up till 0, but while storing it will store only 100 values, because here we have taken my data of 100. Are you getting the point here? If we take my data of 255, then it can store all the 255 values from FF to. If we take my data of 255, then just mute your cell phones. Okay. Just mute your. Then nodri adu yara somebody has unmuted. Just all of you mute your cell phones. Did you get the point, Nandish? Nandish?
Sir.
Nandish? Right.
Yes, sir.
Okay, fine. Let us take one more program here. Before that, let me introduce to this concept here. It's called as data serialization. Data serialization is a concept where we are sending the byte of data 1 bit at a time. We are sending byte data. Suppose say we are sending the value 44H. So 44 is 01000100. Now when we are sending the value 44H serially, serial communication, we have to send bit by bit. All the 8 bits cannot be sent at a time. If we are sending all the 8 bits at a time, then it is not called a serial communication. It will become a parallel communication, correct? That is the meaning of serial communication is, data serialization is, we are sending the byte value serially 1 bit at a time. That is the meaning of data serialization. Okay, 1 bit at a time. We are sending 1 bit at a time. Okay. So that is the meaning of data serialization. We are sending this value through port pins. We are first storing the value in the accumulator, right? A register. Then from A register, we are sending it through the port pins. We are sending it out of the microcontroller through the port pins. Okay. This is the meaning of data serialization. Hope you got the point here. Data serialization means we are sending the byte value. Even though it is a byte value, all the 8 bits cannot be sent at a time. We are sending the bits 1 bit at a time. Okay. Now let us see one program here. Write a C program to send out the value 44H serially 1 bit at a time via P1.0. The LSB should go out first. They have mentioned one condition here. First, read the statement. Write a C program to send out the value 44H serially. The value given is 44H. Instead of 44H, they may give some other value. In examination, instead of 44H, the value may be a different one. Serially, we have to send it 1 bit at a time through P1.0. We have to use the port pin P1.0 to send out the data serially. Now, what is the condition? The LSB should go out first. The least significant bit should be sent out first. So like that, we have to make an arrangement such that LSB bit is sent first, then the next bit, okay, D1 bit will be sent next, D2 bit will be sent next, like that. So serially, the LSB bit will be sent on through the P1.0 pin. Okay. Now for this, what we have to do here? Let us write a C program for this. First, let me explain the concept here. This is a register, A register. Okay, this is a A register accumulator. We have D7 bit, that is the MSB. D0 bit is the least significant bit, that is the LSB. This is P1.0 pin. P1.0 pin. Now, the condition they have mentioned here is the LSB should be sent out first. That is, D0 bin should be sent through P1.0 out of the microcontroller. That means whatever this D0 bit is there, that we have to assign it to P1.0. Accumulator pin P1.0, accumulator bit 0. This is accumulator register. Bit 0 should be assigned to P1.0. Right? And then what we have to do here? Suppose say now the data is 44. They have given 0, 1, 1, 0, 1, 0, 0, then 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, which is given in the program statement. Now 0 is the LSB is 0. This is LSB. This is LSB. Okay. Now this bit is sent out first. So what is stored in P1.0? In P1.0, first 0 will be stored. That is LSB. Okay. Next, what will happen here is we are shifting the data right. We're shifting the data right. Now, once this is assigned to P1.0, so this bit I am rotating right side. I'm rotating right. I'm shifting right side. So the meaning of shifting is, so this bit when it goes here, the right shift. That means the next bit will be coming to this position, right shift. Correct. So in the next position, what will happen? The next this 0 bit, this D1 bit will be in the position of D0. So now the data will be, this 0 will come to here, this 0 will be coming to MSB. So here we have 0, then 0, 1, the same 7 bits will be written as it is. 0, 1, 0 is 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0. Now what has happened here? This bit, that is the next LSB bit, has been shifted to D naught bit. Next LSB bit, that is 0 bit, this has come to this position, that is LSB position, D naught position. Now what I am doing is repeatedly in the for loop, I am putting this, I am assigning this D naught bit to P1.0. That means the next time P1.0, this will be 0, this will be 0. Okay. This will be 0. That is this bit. The next bit has come into the position of LSB. That will be assigned to P1.0. That will be assigned to P1.0. Now again we will shift it. Again right shift. So when I shift it right, this 0 which is already assigned to P1.0 and it is sent out from the microcontroller, then this is shifted right. Again when we are shifting it right, this 0 will come to the position of MSB. Then the first 7 bits as they are 0, 0, 1, 0, 0, 0, 1, 0. Write them here 0, 0, 1, 0, 0, 0, 1, 0. These bits, 4 bits, then remaining 3 bits 0, 0, 1, 0, 0, 1. Okay. 0, 0, 1. Okay. Now what is the LSB, students? It is the next bit. The next bit. It is just shifting right. Okay. Every bit starting from LSB is going on shifting to the right position, right side. Now LSB is 1. Now here what is assigned to P1.0? To the pin P1.0, we are assigning the bit 1. That is the least significant bit now at this juncture. Okay. At this position, it is 1, which is the LSB, that will be assigned to P1.0. Fine. So like this, all the 8 bits are shifted right, and every time they are moving into the LSB position, then from LSB position, I'm assigning it to P1.0, that is ACC 0.0. Accumulator 0th bit, that is D naught bit, I'm assigning it to P1.0 every time. I'm putting it in the form of a loop, for loop, so that every time it shifts right, and after shifting right, the D naught bit, whatever is the D naught bit, that will be assigned to P1.0. Clear here? This is the concept. Now for this concept, we have to write a 8051 C program. Okay. Concept is clear here, students? Data serialization concept is clear here. Now what the condition they have mentioned here? The LSB should go out first. Right? We'll see next part. If the MSB should go out first, then what should be done? That is the next program. Okay. For time being, this program is meant for sending the LSB first, least significant bit first. Okay. Let us write a C program for this. So it is serializing data via P1.0, that is shifting right. Start with the header file, hash include reg51.h, reg51.h, the main function. Before the main function, here we have to define certain bits. So as they are bits, we have to define them. Okay, even though it's a special function registers, all are included in the header file rg51.h. If they are specific bits which we are using, then we have to define them. This we have seen in our previous programs. Correct? Yes bit, special bit, yes bit, P1 B0, P1 B0, that is P1.0. This I am assigning it to P1.0. P1, then this inverted V symbol, P1.0. So what it means here, students? Here P1B0, P1B0, this is nothing but the P1.0, P1.0. Next is I have to consider the accumulator bit. As I told here, I am assigning ACC 0.0 to P1.0. So that ACC 0.0 also have to define it. Yes bit, yes bit. For that, I am using a variable name. I am writing it as register A LSB LSB. This is equal to which bit it is? ACC accumulator 0 bit, accumulator 0.0, accumulator 0.0. Okay. This means that I'm writing in the form of a comment. The variable register A, LSB is equal to ACC 0.0, ACC 0.0, accumulator 0.0, right? Next, let us come to the main function, void main. Then in the main function, perform the initialization. Unsigned character, they have given the data, so I'll define it as unsigned character shift byte, SFT byte is equal to 0x44. Okay, shift byte is equal to 0x44. That is the data they have given. If they give some other value, whatever value they are giving, you have to assign it to this shift byte that we are going to shift. Correct? You can take this variable name, any variable name, but here for our easy understanding purpose, I have taken it as SFT BYTE, shift byte. Next, define the loop index, unsigned character X, unsigned character X. Then come to the for that is assigning the value first. ACC is equal to shift byte. I'm storing the value whatever I am shifting, that I am storing in accumulator first, SFT byte. Then write the for loop for x is equal to 0, x less than how many values? 8 values, 8 bits. It is shifting right side. It's 8-bit register, so 8 bits. X less than 8, x plus plus. Then now we have to assign for x is equal to 0, x less than 8, x plus plus. We have to assign now and then shift the accumulator right by 1 bit. Okay. Now how I have to assign? This is P1B0, that is P1.0. This I have to assign it to ACC 0.0. Okay. Now which should come left and which should come right side? I have to assign the bit ACC 0.0 to P1.0. So P1.0 is the destination, that should come left side. It is P1B0. This is equal to register A LSB. Register A LSB. Okay. Fine. So what it means here? This is P1.0. This is equal to ACC 0.0. This is the meaning of P1B0 is equal to register A LSB. Because we have defined P1.0 as P1B0, ACC 0.0 as register A LSB. This is the least significant bit, ACC 0.0, D0 bit, this one, D0 bit of the accumulator. Next, so once I have assigned, then every time what I have to do? I have to shift the value in accumulator right by 1 bit. ACC right shift. So what is the symbol for right shift, students? It is ACC greater than 1. It is right shift. Okay. So this I have to assign it to ACC again. So it is ACC is equal to ACC right shift by 1 bit. End the for loop, then end the main program. Okay. This is how we are performing the operation of data serialization. What we are supposed to do here, what we are doing here, we are sending the data serially. We are sending the data serially 1 bit at a time, starting from the least significant bit. Starting from the D0 bit, we are sending it to P1.0, then right shift. Whichever is the next bit, D1 bit, that will be stored in the position of D0. Then shift it, send it to P1.0. Next, D2 bit, whatever is there when we are shifting right, that will be stored in the position of D0. Then send it to P1.0, assign it, that will be sent through P1.0. This is how we are performing the data serialization. Is it clear here, students? This program is clear here. Data serialization concept is clear. Is it understood here? This one. Any questions here? Any questions? Yes, any questions here? Bhakti.
Sir, can you explain it once, sir?
You want me to explain once again?
Yes, sir.
Okay, I'll explain it. You understood the concept? Concept is clear, or should I explain the concept?
Concept is understood, sir, the program.
Program you want me to explain? Okay, right. Fine. See, include reg51.h. This is the header file. Then yes bit P1 B0. You can take it any name here. For convenience, I have taken it as P1 B0, which indicates that P1 bit 0. P1.0 means P1 port 1 bit 0. Right? For understanding purpose, easy understanding purpose, I have taken it as P1 B0. That I am assigning it to P1.0. That means wherever in the program I am using P1 B0, that will be replaced by P1.0. This is the meaning of definition. Definition means, defining means wherever in the program I use P1 B0, that is a representation of P1.0. It directly makes use of P1.0 wherever I am using P1 B0. Similarly, I am defining S bit, special bit, register A LSB is equal to ACC.0, accumulator 0 bit, that is this bit, D naught bit. Accumulator, this is the accumulator register, register A. D naught bit is the least significant bit. Clear here? That means this ACC.0, accumulator 0 bit, that is assigned to register A LSB, least significant bit, register A least significant bit. Okay, that means wherever in the program I am using this reg A LSB, that is replaced by ACC.0. It is nothing but as good as using ACC.0 only, but for easy purpose, so that our program becomes simpler, we are using these variable names. Because everywhere if we cannot use P1 this inverted V0, then ACC inverted V0, right? It becomes complex. For easy purpose, so that to make the program simpler, we are using these variable names, and that's why we are defining this P1.0, ACC.0, right? We are defining, and so that wherever we are using these say port pins or single pins, single bits in the program, that those will be referred by some other names. Those will be referred by some other variable names. Okay, so whenever we are using those variable names, it nothing but indirectly we are using those particular pins only, those bits only, which we are meant or which we are assigning it to those variable names. Getting the point here? That is, I have written the comment here, P1 B0 is nothing but P1.0. Then register ALSB is equal to ACC.0. That is, register ALSB is equal to ACC.0. That is, D naught bit of the accumulator, least significant bit of the accumulator is assigned to this variable reg ALSB. Then coming to the main function, unsigned character shift byte, which is the byte we are shifting. What value they have given in the program statement? 44. They have given the value, they have specified clearly that we are supposed to make use of 44 only. If they give some other value, then we have to take that value. And if they don't give anything, then you can assume any random value. Clear here? If they don't give any value in the program, you can assume some random value. Say you can take 44 only, or you can take 47, any random value you take, 8 bit, and then accordingly write the other instructions. Unsigned character X. This is the loop index. X is the loop index. For that, I am declaring it as unsigned character. Then accumulator is equal to shift byte. This data, whatever is given to us, that we have to store in accumulator first. This data, whatever is given to us, that we have to store in this A register, accumulator first. Okay. So it is as good as using move A comma hash 44H. In assembly language, we are using move A comma hash 44H. Right? It is as good as using that statement. Accumulator is equal to shift byte means this 44 value which is there in SFT byte variable, that will be assigned to accumulator. That will be stored in the ACC register or in the A register, accumulator register. Clear here? Now next is for loop. For x is equal to 0, x less than 8, x plus plus. We are shifting how many times? 8 times, because there are 8 bits in a register. We have to shift 8 times so that all the bits will be assigned to P1.0 and it is serially transmitted out. Correct? Therefore, what I am doing, I am using the count value as the loop index x less than 8, x plus plus. Then I am assigning this D naught bit to P1.0. That means I am sending the data from the accumulator. Accumulator means it's a microcontroller. Through this port pin, I am sending out of the microcontroller. Okay. So this later may be interfaced to some device. Through the port pins, I can interface it to some devices, external devices. Okay. So like this, I am sending the data from the accumulator through this port pin. I am sending out of the microcontroller. It is called as data serialization, bit by bit. First, I am sending LSB, then next D1 bit, D2 bit, D3 up till D7, bit by bit. Okay. Now, if I want to send this serially, bit by bit, then I have to shift the data right side. So that I'm sending from the LSB first, then next D1 bit will be stored in the position of D0, that will be stored in P1.0. Then next D2 bit will be stored in the position of D0, that will be stored in P1.0. Like this, I'm sending out serially, starting from D0 bit to D7th bit. Every time I have to shift right. Okay. Now for the first time, what I'm doing, I'm assigning. That is P1.0 is equal to ACC.0. P1B0 is equal to register ALSB. That is P1.0 is equal to ACC.0. That means in the P1.0, first the D0 bit of the register A will be stored. What is the D0 bit for the first time? It is 0. I have marked it here. As you can see here, this 0 bit will be stored in P1.0. Okay. Now once it is stored, I have to shift it right to get the next bit. Next bit. D1 bit should come in the position of D0 because they have mentioned LSB should go out first. Right. To get that bit, what I have to do? I have to shift right. ACC is equal to ACC accumulator shift right by 1 bit. The meaning of this 1 is we are shifting by 1 bit. Okay. So every time we are repeating it. Right. Every time we are repeating, even though we are shifting it right by 1 bit only, we are using in the for statement, for loop. So every time it goes on shifting right by 1 bit up till the final count value is reached. Correct. So it is shifting right by 1 bit. Next time, what will be the value in A register? 00100010. This 0 will be stored in the position of MSB. So this is the LSB which has come here, Okay. Then these 7 bits, they are shifted right by 1 bit. This 0 will be stored in one position of 1, 1 will be stored in the position of 0, right? Then this 0 will be stored in this position. It is 0, 0 will come to this position, this 0 will come to this position, this 1 will come to this position, right shift. This right shift. We got this value. Now what is the bit in LSB? It is the D1 bit. This bit has come into this position, D0. Are you getting the point here? Therefore, this D0 is now assigned to P1.0. Next time, x is equal to 1. X is equal to 1. Correct? Therefore, what is the, we have shifted it right by 1 bit. Accumulator is equal to accumulator right shift by 1 bit. Next time, P1B0, P1.0 is equal to ACC.0. ACC.0 is what now? It is the next bit, next higher bit. That is D1 is stored in D0. Yes or no? That means this D0 will be assigned to P1.0. P1.0 is equal to 0. Next time when you shift it right, again that is instruction. ACC is equal to ACC greater than 1. That is right shift by 1 bit. That is executed. When it is executed, it is right shifted by 1 bit. That is LSB will be stored in the position of MSB. So this is 0, which is there, right? This 0 that will be coming to the position of MSB. Then each bit are shifted right by 1 bit. This 0 will be stored here, this 0 will be stored here, this 1 will be stored here, like this. Correct? Now this 1 will come to LSB position. This 1 is stored in P1.0. So this continues up till how many times? 8 times. X less than 8 means 0 to 7. Right? When it repeats for 8 times, all the bits are shifted from the A register to P1.0, from where it is transmitted out from the microcontroller. That is serial communication. That is how the program executes. You understood here, Mole? Now you understood?
Yes, sir.
Okay, fine. Any other questions here? Any other doubts? If anybody else is
No.
having any other doubts? Just see. Bharti? Jyoti?
Yes, sir. Understood, sir.
Okay. Mantesh?
Understood, sir.
Right. Nandish?
Yes, sir, understood.
Okay. Shabaz?
Yes, sir, understood.
Okay. Shafia?
Sir, understood, sir.
Any questions, Shafia?
No, sir.
Okay. Sushti? Sushti? Taik Mohammed? Taik Mohammed?
Sir, understood.
Any problem in understanding Taik Mohammed?
No, sir, no.
Okay. Aishwarya? Aishwarya?
Yes, sir.
Concepts are clear, Aishwarya?
Yes, sir.
Okay, fine. Shodhan? Shodhan?
Yes, sir, understood, sir.
Logic, everything is clear?
Yes, sir.
Okay. Shashidhar? Shashidhar Gowda? Sridhar? Sridhar? Badiger? Saish? Saish? Is it understood, Saish? Okay. In the next class, we'll continue with the few more programs on data serialization. Right? Few more programs are remaining. And then we'll start with the next part of the module. That is next section of the module that we'll be starting. We'll complete the remaining programs in data serialization. And then I will take up the next half of the third module. Okay. That will take up in the next class. Thank you.